Hi, in this video we will discuss about cracking the WEP or wireless equivalent privacy encryption. The WEP protocol has known to be flawed even since early 2000, but is still in use these days and the access points are still providing WEP capabilities. The fundamental weakness in WEP is its use of RC4 or Rivas Cipher 4, which is a stream cipher, and a short IV or initialization vector value that is recycled every 224 frames. While this is a large number itself, there is a 15% of 4 reuses every 5000 packets. To use this in our advantage, we generate a large amount of traffic so we can increase the likelihood of IVs that has been reused and thus compared to ciphertext encrypted with the same IV and key. Let's see what all this means in practice. We'll start by enabling WEP encryption in our access point. For that, we navigate to the Wireless tab and from here we select Wireless Security. Right now the security mode is disabled, meaning that our access point uses no encryption. Let's enable WEP by selecting it from the list of available security modes. This will allow us to enter a key that is going to be used in data encryption. We will use the default transmit key 1 in this case, and for key 1 we will enter a value. You can enter a complex value here or a simple one, as in my case. For simplicity, I will use the previous entered value of ABCD 1, 2, 3, 4, 5, 6. So this will be our encryption key. Let's save it and apply the settings, and let's switch to the PuTTY window, which is already connected to my Kali Linux machine. We'll start by putting our wireless adapter into monitor mode, so we will be able to capture the wireless traffic. We can do that by using the rmon-ng start followed by our wireless interface WLAN 0. We can see a confirmation that the monitor mode has been enabled on mon0 interface. Now let's use this interface to display a list of available wireless networks by using arondump-ng mon0 command. The wireless network that we are interested in is called Wireless Lab, and we can see that this is currently using WEP encryption. I will copy the MAC address of the access point as we will use it shortly. Next, let's obtain more information about this specific wireless network. We can do that by using the arrodump-ng followed by the -b option and the MAC address that we just copied earlier, followed by the minus channel, and as we can see our access point is using channel 6, and then we specify that we want to save the wireless packets into a pcap file. So we put --right followed by the prefix of the file. We will use a file called WEP in this case. And we finish the command with the interface that we want to use, which in our case is mon0, the monitor interface. As we can see, there are no clients currently connected to the wireless network. Let me connect my phone as a legitimate client and see what happens. Okay, I've successfully connected my phone to the wireless network and we can see its MAC address in the clients list. Now let me open a new PuTTY connection to the Kali Linux machine as we will need it to run multiple commands simultaneously. So I will connect to the Kali Linux machine and let's first check if the arrodump command issued earlier is indeed saving the wireless packets into a file prefixed with WEP. For that we type the ls command, which lists the files and folders located in the current directory. As we can see, there are multiple files available having the WEP prefix. The file that we're interested in is called wep-01.cap or capture file. Now that we have the necessary information about our wireless network along with its connected client, we can use it to generate traffic in our wireless network. We will capture ARP packets on the wireless network and inject them back to simulate ARP responses. ARP stands for Address Resolution Protocol and is a communication protocol used for resolution of network layer addresses. For that, we will use the areplay-ng tool, followed by the -4 option, which specifies an ARP reply, -B option, which specifies our access point MAC address, and -H options, which specifies a MAC address of a connected client. We need a client to be connected to the wireless network, so we will be able to send out the ARP packets. Without a connected client, our attack will fail. And oops, I forgot to supply the interface that we are going to use, which is mon0. So I will run the previous command one more time and will supply mon0 at the end of it. After a few moments, we can see that AirReplay was able to sniff ARP packets and started replaying them into the network. At this point, AeroDump will start registering a lot of data packets. This is exactly what we wanted to achieve, to generate lots of wireless network packets. All these sniffed packets are being stored in the WEP file that we specified. Let's start the actual cracking part. In order to do that, we run another PuTTY application and connect to the Kali Linux machine, while leaving the other two PuTTY sessions running in the background. We log in into the Kali Linux machine, and in order to start the web cracking, we issue the aircrack-ng command, followed by our packets capture file, the web file that has the cap extension. This is the actual application that will try to crack the WEP key. I recommend that you leave the other two utilities running in the background while aircrack is trying to break the WEP key. We can see that so far we got about 18,000 initialization vectors. The higher the number of IVs, the higher are the chances that the WEP key will be cracked. So we just leave it running, and after a few moments, we can see that the key has been successfully cracked. The key is ABCD 123456, the same as the one that we used when we enabled WEP encryption in our access point. So, in order to crack the WEP key, we waited for a legitimate client of the network to connect to the access point. After this, we used the areplay-ng tool to replay ARP packets into the network. This caused the network to send ARP replay packets, thus greatly increasing the number of data packets sent over the air. We then used the aircrack-ng tool to crack the WEP key by analyzing cryptographic weaknesses in these data packets. Note that we can also fake an authentication to the access point using the shared key authentication bypass technique that we learned earlier in this course. This can come in handy if the legitimate client leaves the network. This will ensure that we can spoof an authentication and association and continue to send our replied packets into the network. So, to conclude, web encryption is flawed by design and is 100% crackable. Do not use it in order to protect your network. Use other encryptions type like WPA or WPA version 2. These two can also be cracked, but they are offering a higher level of security, as we will see in the next video. Thanks for watching, and I'll see you in the next lesson.